Hello students, welcome to another video lecture on first year physics. So students, today we are going to discuss one of the most confusing topic from first year physics. We are going to discuss significant figures. Generally we define significant figures as the accurately known and the first doubtful digit. So in any measurement, if we can guess the accurately known digit and the first doubtful digit, so those digits actually gives us the number of significant figures. Okay, so why we need significant figure? Because it gives us an idea about the precision and accuracy of any measurement. Like in any measurement, the measurement can be precise and the measurement at the same time can be accurate. So what does mean by this precision? Precision is something which is related with the least count of the measuring instrument. So if the least count of a measuring instrument is very small, then the measurement taken from such an instrument will be highly precise. And it depends upon the better calibration of that instrument, right? And accuracy, on the other hand, is the extent of how much close the measured value is with the actual value, right? So it has nothing to do with the least count of the measuring instrument. So that's why it is important to study significant figures. Okay students, now there are 6 to 7 rules in order to identify significant figures, and you can find those rules in your textbook, right? But most of the time students get confused and they can't memorize them all the time and they can't remember them. So I am going to try a different way in order to understand those rules, and you can subconsciously apply those rules in order to identify significant figure. Okay, like for any measurement we generally use decimal system, right? And decimal system start from 0 up to 9. So for any measurement we use decimal system, and in decimal system we are having numbers which start from 0 and then goes on up to 9. So the first point is that all non-zero digits, they are significant, right? We can write S for significant and NS for non-significant. Now, what about 0? Because decimal system also have 0, right? So for zeros, we are not sure whether they are significant or not significant. Or actually we can say that, sometimes the zeros in any measurement can be significant and sometimes they cannot. So for zeros, in order to identify that whether the zeros in our measurement, whether they are significant or not, we have further divided it into two categories. The first one is significant, like when the zero will be significant. And when the zero will not be significant. Not significant. Non-significant. Okay. So the first point, all the zeros which are trapped are significant. So I can shortly write that trapped zeros, let me put it like that. So for zeros I can write like this. So all trapped zeros are significant. For example, 101 without decimal point, this is significant. Or with a decimal point, 10.01. Now you can see we are having decimal point and both the zeros are trapped between two non-zero digits, so they are significant, right? Okay. Now all zeros trailing having decimal points are significant. So I can shortly write trailing zeros with decimal points are significant, like 1, 2.00. Both these two zeros are significant because they are following a non-zero digit, and we are having a decimal point over here, right? Let's take another example. 0.0020. Now here you can see we are having decimal point, but these two zeros, they are not trailing, they are leading one, right? But what about this one? It is a trailing zero after a non-zero digit, and we are having a decimal point in this value, so this would be significant. So here we are having two significant figures. Now what about leading zeros? So let's come toward non-significant. All leading zeros are non-significant. For example, 0.0125. So you can see both these zeros are, let us consider this one. We are having a decimal point, but anyhow it is not trailing, it is actually leading a non-zero digit. So such a zero would be considered as non-significant, right? You can take many examples. 0.00301. Here these two zeros just after the decimal point are non-significant, and the one which is trailed between two non-zero digits according to this rule are significant, right? So all the leading zeros will be non-significant regardless of whether you are having decimal point or not, and all zeros which are trailing and having decimal points are significant. Okay. What about trailing zeros without decimal point? So this is the most important point. Trailing zeros without decimal. Most of the time students get confused at this point. Like, let me give you an example. What about 1200? We don't have any decimal point here, right? And both these zeros are trailing. They are just after a non-zero digit. Let's take another example. 2000. Okay, so generally we can consider them as non-significant figure, but sometimes they may appear as significant figure, and in order to find whether they are significant or non-significant, we have to look at the least count of the measuring instrument. So depending upon the least count, these zeros can be significant, and they sometimes cannot. We can have 4 significant figure, we can even have 3 significant figure, we can even have 2 significant figure, because these zeros, they can be significant depending upon the least count of the measuring instrument. So generally we can say that here we are having 2 significant figures and here we are having 1 significant figures, but depending upon the situation, if the measuring instrument or the least count of the measuring instrument suggests any of the zero to be a kind of significant figure, so we can consider that as a significant figure. So you have to remember these fingertips rules in order to identify significant figures. Okay, there are 2 other points which are important. System of unit doesn't affect the number of significant figure. Like let me give you an example. If we find the mass or the length let's consider mass to be 0.1 kilogram, it will be having one significant figure. We can also write this value as 100 gram, right? Again, here we will be having only one significant figure, as we discussed in our last case, that if any zero having no decimal point, which is actually trailing a non-zero digit, is considered as non-significant figure, right? Okay, D, if we write any value in scientific notation, like let us take an example, 2.1 multiply 10 to the power 3. So we are not supposed to take the power of 10, right? So the digits other than the power of 10 are considered as significant, the number of digits. So here we are having 2 digits, so the number of significant figure will be 2, right? So I hope that you can remember these rules in order to find significant figure. Let us solve some of the example in order to clarify the concept further. The first example we are having 20.000. So just remind what we did last time. All the zeros which are trailing and having decimal points are considered to be significant, and the non-zero digits, they are always significant. So how many significant figure will be here? So the number of significant figure will be number of significant figure, right? So in this case we are having 5 significant figures. What about this one? Now the zeros which are leading a non-zero digit, whether they have decimal point or not, so they are non-significant. So we can ignore this zero, and all trapped zeros are significant. So this is trapped between 2 and 1, right? So it is significant. So the total number of significant figure will be 4. Okay. What about this one? The non-zero digits are significant. The zero or the trailing zero and having decimal point is significant. So we are having 4 significant figures. Here it is trapped and the other zeros are trailing and we are having decimal points. So all these digits are significant. So total 5 significant figures. 101. This zero is trapped between 2 non-zero digits. So 3 significant figure. 0.080. Now this zero, just after the decimal, this is leading a non-zero digit, so they are non-significant, and a non-zero digit is always significant. And what about this zero? Trailing zero having decimal point is significant, so we are having total 2 significant figures. Let us take a special case. What about 5? Okay, let me bold it. 5,000. How many significant figure will be there? We can't be sure. We can have, number of significant figure can be 1, it can be 2, it can even be 3 and 4. Now how we are going to find that whether the number of significant figure is 1, 2 or 3 or 4, right? So for that we have to look at the measuring instrument and its least count. If this is a kind of distance, right, and if we are representing this distance in kilometer, then there will be only one significant figure. But if you are using a meter stick in order to find that much distance, then the number of significant figure will increase, right? So depending upon the least count, we can assign the number of significant figure in such a case. Okay, I hope that now you can clarify all your misconceptions regarding significant figure, and even you don't have to memorize those 6 rules, right? So you can just conceptualize all these points in order to figure out that how many significant figures are there in a measurement. Okay, For more videos, like, subscribe and share. And please don't forget to click on the bell icon.